Okay, welcome back. We're going to be working on Unit 3. This is Lesson 4, Solving Quadratic Equations by Factoring. This is essentially what we've been doing all unit. We're just now extending a little bit by giving different examples of factoring and seeing the possibility of rearranging equations and using different forms of factoring. So right now, getting into it, anytime a question in math asks you to solve dealing with a quadratic, that means that you have to find the zeros. So right now we're looking at this word solve. That's what this whole unit has been about, solving for quadratic equations. For solving, we're finding the zeros. The next unit, we're going to be asked to find the max or the min. That's going to be completing the square and solving for the vertex. So right now, in this unit, all we're doing is factoring. If I look at this first example, I've got negative 63x plus 133x minus 7x squared. So my first step would be to rearrange this equation so it's in the proper form. So we know we have to lead with our highest degrees, which is the negative 7x squared, followed by that negative 63x plus 133x. Now, when I said negative 63x and 133x, we should have thought to ourselves, why are those two terms separated? They're both like terms. So like terms should be collected. They should go together. So right now I'm going to add negative 63 to 133 and end up with positive 70x. Now, looking at this equation that I have left, this quadratic, I've got two terms separated with a plus sign, so though that isn't a difference of squares, but I can definitely try greatest common factor. So my lowest number is negative 7, so I'll try that. Negative 7 does go into 70. I have two x's with the first term, one x with the last term, so I can take out an x. This, of course, goes in the front. And then we're left with x minus 10. Now I'm going to separate Now the reason why I've set them equal to 0 one more time is because that 0 represents the y value and we're solving for x, and the x-intercept occurs. So if I'm drawing a little graph here, the x value, if we're trying to solve for that, the y is always going to be at 0. So we're setting them equal to 0 to be able to solve for x. So for my first x, it's negative 7 times x equals 0. So to undo that multiplication, we'll divide. And of course, 0 divided by 7, or negative 7, is 0. So one of my x-intercepts is at 0. The next intercept, I'm going to bring that negative 10 over. It'll change to a positive 10. So the other x-intercept is at 10. Now, x squared minus 2x minus 24 for b. I want you to look at the solution, or I want you to try it on your own first, and then look at the solutions in your notes. The next example, which I'll do with you, is 9x squared minus 25. Now, if I look at this, I'm going to try greatest common factor. My lowest number being 9. Well, that doesn't go into a 25, so what else goes into a 9? A 3. 3 doesn't go into 25. So then I'm going to be left to think of my other forms of factoring. I've got two terms there, so two terms with a minus sign. Oh, that could be a difference of squares. So let me check. Can I square root 9x squared? And can I square root 25? Yes, I can. So we'll separate them into our two brackets using the difference of squares method. The first bracket with a positive in between the two terms, and the second bracket with a negative. Then we'll square root 9x squared to become 3x. We'll write that in our first placeholder. And then the square root of 25 is 5. So now we need to separate and solve, which means that we'll set both of these equal to 0. And then we'll perform opposite operations to solve. So I'll bring over the positive 5 and the negative 5 to end up with negative 5 and positive 5. Then to undo 3 multiplied by x, I'll divide by 3. And then I'll be left with x is equal to negative 5 over 3. which of course you can express as a decimal. And then you can write negative 1.6 if you want. And x is equal to positive 5 over 3, which again you can express as positive 1.6. Now for D, 4x squared plus 20x minus 25. The issue here is this negative 25. It's on the wrong side. It needs to move over to be a part of the equation of the quadratic, and it has to be set to 0. So I'd start off first by moving that 25 over and setting the equation equal to 0. Then I tried greatest common factor. So I tried to divide the 20 by 4 and the 25 by 4, which doesn't work. So the next number that goes into 4 is 2. That also doesn't work. I can't take out any x's, so then this will be an example of decomposition. So with decomposition, we're going to multiply a by c to come up with a new product, so sum and product. So what we're just basically doing is using the forms of factoring, again from Unit 2, and we're coming up, and we're just adding an extra step of setting them equal to 0 at the end and solving for those x values. So 4 times 25, the new product being 100, or a positive 100. Two numbers, of course, that multiply to give you 100 and add together to give you 20 are 10 times 10, and 10 plus 10. Now it isn't just as simple as writing an x plus 10 and x plus 10 with decomposition. Of course, you're splitting the middle term and you're grouping the first and last terms with your two numbers, two solutions that it doesn't matter which one you put where. And in this case, they're both exactly the same. So 4x squared plus 10x, and then 10x plus 25. Now after we've grouped, we'll use greatest common factor. So 4x squared plus 10x. I'll try to take out a 4, it doesn't work. So then I'm left with a 2 that I can take out. I've got 2 x's and 1 x, so I can take out 1 x. Then from my next one here, 10 and 25, I'll try to take out a 10. That doesn't work. So I can take out a 5. I can't take out any x's. Those greatest common factors move to the front. So I'll be left with 2x in the front. Then 2x plus 5 plus 5, 2x plus 5. I'll group the greatest common factors together, 2x plus 5. And I'll write one of the binomials, which is also a 2x plus 5. The reason for this is a perfect square trinomial. So both zeros are actually occurring at the same point. This means that the x-intercept is also the vertex. We'll learn about this later on in the next unit. But now I'll solve. So 2x plus 5 is equal to 0 on both sides. We'll bring the 5 over. And divide by 2. So both the x-intercepts are at the same point, which is at negative 2.5. So if you want to look ahead towards the next unit, if both x-intercepts are occurring at the same point, then that means that this parabola, either going up or down, the vertex and the x-intercept are the same point. So they're both occurring, they're just touching or sitting on that x-axis. So there aren't two distinct x-intercepts. There's only one x-intercept. Okay, for this next example, E, again, what we're doing is just taking or adding one step and taking a little bit further each and every time. So if I look at this this example here, 2 bracket x plus 3 bracket squared equals 5 bracket x plus 3. My first step would be to expand this x plus 3 to the power of 2. That's because when I use BEDMAS, I'm going to be doing brackets which I don't have any brackets. I know you can see brackets in there, but brackets means that you're solving inside, and I don't have any solutions that I need to do. There's no grouping. So the next step that I would do would be the exponent for BEDMAS. So that means that I'm going to be expanding x plus 3 to the power of 2. We've already done this in the first unit, and I taught you the short form in the second unit. If you're still expanding using FOIL, cool. You'll be using x plus 3, and then you'd use your FOIL method. So x times x, 3 times x, 3 times x, 3 times 3, and you'd group your middle terms. This is what x plus 3 to the power of 2 is. So now we'll replace it. Then we'll use distribution to break the brackets, because that's multiplication. So 2x squared plus 12x plus 18 is equal to 5x plus 15. Now what we want to do is bring all of our terms to one side. So I'm going to take this 5x and this 15 and bring them over so that the equation can be set to 0. I chose to bring those over because there's only 2 of them while the other side has 3. So when I do that, I'm going to group them together. So 2x squared plus 12x minus 5x, because that positive 5x became a negative when I brought it across the equal sign, plus 18 minus 15 is equal to 0. So I just wrote them beside each other to show that grouping. So now 2x squared, and then we have 12 minus 5. We're going to end up with 7x, and then 18 minus 15, positive 3. And now we've arrived at a stage where we have our quadratic equation in standard form, and now we're going to have to actually start factoring. So for this one, I would try to take out a 2, doesn't work. Try to take out an x, doesn't work. That means I'm going to be using the method that I did before of decomposition. So sum and product, we have to multiply 2 by 3 and add up to 7. The two numbers that will multiply to be a 6 and add to be a 7 are just 6 times 1. So now we'll group 2x squared plus 6x, 1x plus 3. We'll take out a 2x. And then from my right side, I can't take out anything. So remember that there's still a 1 in the front, which that would be that 1 that we've taken out. So I'll write my greatest common factor of 2x in the front. We'll have x plus 3 plus 1, x plus 3. Then we can finish it off by grouping 2x plus 1, x plus 3, and then finally solving. So now we'll need to separate 2x plus 1 equals 0, x plus 3 equals 0. We'll take that positive 1 and bring it over, and then divide by 2. So one of my x-intercepts is at -1/2. or negative 0.5. And the next x-intercept, take the 3 and bring it over, is at negative 3. Now for the last example here, we just got decimals, so not nice numbers. I want you to first start off by bringing over that 1.8, then practice solving using your methods of greatest common factor, difference of squares, decomposition, or sum and product, and then check your solution in the notes. Now, for this next example, it's asking me to determine whether the given number is a root of the equation. So if I look at the given x-intercept or x value being negative 1, and then I look at my equation over here, I've got 5x squared plus 7x equals 2x squared minus 6. Now what I could do is bring everything over to one side and then solve, which means to factor, right? And then find the zeros. But I've got an easier way. This equal sign means that the left side and right side are equal, which means that they're the same. So then if I input this x value in to the equation where x is, and then solve for the left and right side, they should be equal. So I'm going to try that right now. 5 multiplied by negative 1 to the power of 2 plus 7 multiplied by negative 1 should be equal to, or the same as, and I'm just going to put a line there, kind of like a wall dividing the two, 2 multiplied by negative 1 to the power of 2 minus 6. Now I should be able to type the left side and right side into my calculator and be able to solve. But right now, negative 1 times negative 1 is 1. 1 times 5 is 5. 7 times negative 1 is negative 7. Negative 1 times negative 1 is positive 1 times 2 is 2 minus 6. 5 minus 7 is negative 2. 2 minus 6 is negative 4. They're not the same value. They're not equal. Therefore, x equals negative 1 is not a solution. It is not a given root. Now looking at the next example of a word problem, we'll find many of these in our textbook. Something going up, something going down, how long did it take, when did it hit the ground. So in this example, I've got a model helicopter which is shot into the air. Its path can be approximated by this function, negative 6t squared plus 42t. Of course, h is the height in meters, t is the time in seconds. When will this helicopter hit the ground? So again, this whole unit has been about factoring, solving for the zeros, and then setting them equal to 0 to be able to find the x-intercept. So this helicopter is going up in the air and then coming down and hitting the ground. They don't want to know how high the helicopter goes. They're not asking that. What they're asking is when the helicopter hits the ground. And they're asking me for the time, which are these x-intercepts. So we're just going to do what we've always done. Start with our equation. We're going to begin by factoring. So by looking at this equation, negative 6t squared plus 42t, I know that I can't lead with that negative sign, so I'm obviously going to be taking out a negative number. Now let's see, 6 and 42, does a 6 go into a 42? Try to divide them on your calculator and make sure that it's a whole number. It does. So I can take a negative 6 out of both. And then I've got a t squared and a t, so I can take out 1t. I'll write that greatest common factor at the beginning. Then write my remainder, so negative 6t squared divided by negative 6t ends up just being t. 42 divided by negative 42 divided by negative 6 is negative 7. We had 1t with that 42. We took that away. It's now at the front. So now we'll separate, set them equal to 0, and we'll solve for the time of when the helicopter hit the ground. So 0 divided by negative 6 is 0. Negative 7, move that over. We're at positive 7. So just like this little sketch that I did off to the side, the helicopter is starting at 0 seconds, goes up into the air, and then falls, and it hits the ground after 7 seconds. You write your therefore statement. The helicopter hit the ground after 7 seconds. Now for lesson number 5, because we're working at a different pace here, for this lesson, all I want to do is stay on track with this factoring method. So we're not going to be solving with a table of values or with graphing. For right now, I just want us to use this method of factoring. So you can practice, use this as a minds-on, as a sort of what do I remember. I want you to try to use the steps that we've done throughout this unit for negative 2x squared plus 32x minus 100 and be able to solve for the zeros and then ultimately determine if we've got a maximum or a minimum and where that maximum or minimum occurs. That's asking you to solve for the vertex. Okay, so pause the video now and try this one on your own. Okay, great. Now that you've tried it on your own, check your solution. As a quick review, the first step to finding that max or that min is to take our equation and factor it. I tried greatest common factor first, and I was able to pull out a negative 2. So I wrote that negative 2 in front of my equation. Then I divided all 3 terms by negative 2. That left me with x squared minus 16x plus 55. Looking inside the bracket, I then knew that I've got 3 terms there, so I've got to use sum and product. So I made my chart with the sum being negative 16, the product being positive 55. I found that 2 numbers that worked to satisfy the sum and the product were negative 5 and negative 11. Because the value in front of that x squared was a 1, all I had to do was write my 2 brackets, x minus 5, x minus 11. Of course, that negative 2 doesn't go anywhere. It stays at the front. I don't get rid of it. Now, when I'm asked to solve, I don't worry about that negative 2. Why am I not worrying about that negative 2? Because it's not with my x or the other x. So I separate those 2 x's and set them equal to 0 to be able to solve. So I've got one x-intercept at 5, the other x-intercept at negative 11. Then I find the midpoint between those 2 x-intercepts. The way that I do that is that I add them up and divide by 2. So 5 plus 11 divided by 2 gives me my x value of 8. This x value is the x value of your vertex. So this is where your max or min is going to occur at. And how high that max or min value is, determining whether it's a maximum or minimum, well, I need to solve for my y value. So I'm going to take that 8 and then sub it into the equation, go back to the original, and we end up with 18 for that y value. I gave myself a little sketch here. So my 2 x-intercepts are at 5 and 11. In between 5 and 11 is 8. I plugged in 8 and I got a height of 18. My parabola is facing down from that 18. How do I know it's facing down? Well, it's got to cross through 5 and 11 and it's as high as 18. But also if I go back, my equation has a negative sign for my a, and I should already know that that a being a negative means that the parabola is pointed down. But just from the points alone, there's no other way to draw this parabola. You couldn't draw this parabola pointed up from 18 and 8, because then if I tried to draw going up, it wouldn't cross at 5 and 11, correct? So as you can see, I've tried to make this unit pretty focused around the repetition of these skills to be able to factor, solve, find the midpoint, and then ultimately determine what the max or min value is. I've gotten rid of a lot of the other stuff in this unit. So now we're just going to look at different word problems, and then I'm going to move on to the last lesson and just do one example of determining an equation from a graph. Okay, great. So now looking at this one word problem, Sally standing on the top of a river slope and throws a ball. The height of the ball at a given time is modeled by this function. Then it gives me my equation where the height is in meters, the time is in seconds. When will the ball be 10 meters above the ground? So right now we've got this river and we've got this ball being thrown, and she's already at a height and then she's throwing it off. So right now actually we can see that we've got a y-intercept in this standard form of 250. So we should know that that y-intercept is our time at 0. So I'm a visual person, so I got to make a graph here. I know that right now Sally is standing on a pretty tall hill that's 250 meters up in the air. And she's going to take this rock and throw it. And the rock's obviously going to go down towards the ground. And of course, because it's a parabola, it's also going to go down towards the ground in that negative time that we know doesn't exist. So right now, at a time of 0, she's at 250 meters above the ground. And now that we start timing her, the rock is ultimately going to get lower than that as time goes on. And we want to find when the ball will be 10 meters above the ground. So what we need to do is solve when this 10 meter height occurs, when being what time this ball is at, or sorry, this rock is at 10 meters from the ground. So to find these two times, and of course one of those times is going to be a negative number, we can see that from our little sketch, and the other one will be a positive, we're going to have to sub in our required height of 10 meters into the equation and then solve. And what does that word solve mean in math? It means finding the zeros. So this equation that's given to me, I'm going to replace the height with 10. But then I can't have that 10 on the other side of the equal sign. So I'll bring it over to set it equal to 0. When I take that positive 10 and bring it over, it'll become negative 10. So now at the end, I've got positive 240. And now I'll begin my factoring. I've got negative 5t squared minus 10t plus 240. I can clearly take out a negative 5 from this equation, which is the greatest common factor. Can't take any t's out. So I'll be left with t squared plus 2t minus 48. Then I'll use my sum and product method. Two numbers that add together to give me 2 and multiply to give me negative 48. Those two numbers are going to be an 8 and a 6 because they're 2 apart, and they also make that 48. Now I want to make a negative 48 and a positive 2, so the sign of the sum will go with the bigger number. That means that my 6 will be a negative because 8 minus 6 is positive 2. Then because it's a simple trinomial, because there's a 1 in the front, I'm going to, and we're not looking at that negative 5 when I say that there's a 1 in the front. We're looking at the coefficient in front of that degree to the power of 2. So because I've got that 1 there, it's simple, which means that I'll do t plus 8, t minus 6, because those are the two values that work for my sum and product. And then we'll solve for that time by setting it equal to 0. So we've got one time at -8 and the other time at +6. The time that we'll ignore is the negative time. So when will the ball be at 10 meters? After 6 seconds. So just make sure that you write your therefore statement that the ball will be at a height of 10 meters after 6 seconds. Now for 3.6, creating quadratic equations. To create a quadratic equation, the only example I want to review, don't want to go any further with this, is creating a quadratic equation given a graph. So here's the example that we've been doing in our homework to determine the equation in factored form from the graph represented. So to start this off, you should know the factored form equation, which is y equals a bracket x minus r bracket x minus x. So just to review, r and s are your x-intercepts, and remember that the rule of switching the signs applies because of this negative sign that's in our equation. So we're ultimately going to be replacing r and s with our x-intercepts. Then we're going to be replacing these x and y values with a point to be able to solve for a. A is going to be that tricky value, that stretch and compression, that up and down value that we need to solve for to finish off our equation. So step number 1 is going over and identifying our x-intercepts. So for these two x-intercepts, highlight them. You'll have one of them at -5 and the other x-intercept at +2. So these two x-intercepts, I'll start off by writing what they are. The x-intercept, one of them is at -5. The other x-intercept is at +2. We'll replace the r and the s value with that -5 and that +2. And of course, when we replace them, we're going to write the opposite in. So I've got a +5 and I've got a -2, because when I take those values out, when I set them equal to 0, they're going to be -5 and +2. The next thing that we can do is choose a point on my graph, either an x or an x and y value for that point. Now, one of them is already given to me, which is pretty nice, right? I mean, it's the vertex. You can easily substitute that point in, and it will work, of course. But that's like the best case scenario. So I want to show you where you can choose any point, and you'll have to read those points. So if I look at this graph a little bit more carefully, I can't read any of these points here. They're too hard to read, but this point is readable. It's at 0 for x and 20 for y. So if on the test I don't give you the point as nicely as this example is doing, you'll have to find a point that is readable on the graph that you can substitute into the equation to be able to solve for that a value. So right now you can use 0, 20, or -1 and 24. I'm going to use that 0 and 20 just because I solved for that point, so I feel pretty good about it. So y is 20, a I'm solving for, x is 0. Then I'll begin to solve inside my bracket. 0 plus 5 is 5. 0 minus 2 is -2. A times 5 times -2 is -10a. I'll divide by that -10 in front of my a to find out that my a value, 20 divided by -10, is -2. Fantastic. Now at the end, I'll write out my equation. Y equals -2, bracket, x plus 5, x minus 2. Remember, when you're writing out your final equation, Make sure that you always leave your x and y as variables because it is an equation. So there will be many different x and y values. If you look at your parabola here, there's actually, if you remember when we were doing domain and range, there's infinitely many x and y values because there are constant or continuous points along this quadratic equation. That's where we're going to leave unit 3 in this difficult time period that we're in. We're just going to focus around solving equations. Solving means factoring and setting those zeros or solving for those zeros, and then determining the equation of a line or solving for the max and min value, which means to solve for the vertex.